Good morning, everyone. So yesterday we were doing questions from exercise 10.4. Just we started with one question, and I hope you know how to find the cross product of two given vectors. So the cross product of two vectors A cross B, it is denoted by A cross B, and this is a vector which is perpendicular to both A and B, both vectors A and B. A cross B, which is a vector perpendicular to both the vectors A and B. And you know how to find this A cross B when A and B are given in component form. When A and B are given in component form, A cross B is equal to value of the determinant I, J, K, then A1, A2, A3, that is the scalar components of vector A, and B1, B2, B3, which are the scalar components of vector B. So let us write the question. Find the unit vector perpendicular to, find a unit vector perpendicular to each of the vectors A plus B and A minus B, where A is equal to 3i plus 2j plus 2k and vector B equals I plus 2j minus 2k. See, you find a unit vector. You have to find a unit vector. That means the magnitude must be equal to 1. And the vector must be perpendicular to A plus B and A minus B. Where vector A and vector B are given to us. See, a vector which is perpendicular to both A and B can be found by finding A cross B. Okay, a vector which is perpendicular to both A and B is A cross B. Similarly, you have to find a vector which is perpendicular to both A plus B and A minus B. What you have to do? See, this is the basic concept here. A vector which is perpendicular to both A and B is A cross B. Here you have to find a vector which is perpendicular to A plus B and A minus B. So what you have to do here? Give your answer. A vector which is perpendicular to both A and B is A cross B. So if you want to find a vector which is perpendicular to A plus B and A minus B, what we have to find here? Yes, exactly. You have to find A plus B cross A minus B. See now, a vector which is perpendicular to A and B is given by A cross B. So here the question is find a vector which is perpendicular to A plus B and A minus B. We have to find A plus B cross A minus B. So let us find A plus B first. A plus B is equal to adding these two vectors. To add two vectors, we have to add the corresponding scalar components. 3i plus I, which gives 4i. 2j plus 2j, which gives 4j. Then 2k minus 2k, which becomes 0k. A minus B is equal to subtracting the corresponding scalar components. So 3 minus 1, it is 2i. Then 2j minus 2j, it becomes plus 0j. Then 2k minus 2k gives 4k. Now you got A plus B and A minus B. A plus B cross A minus B. So you are having two vectors here in component form. To find their cross product, we have to find the value of the determinant I, j, k. Here 4, 4, 0. Then 2, 0, 4. Find the value of this determinant. Expand this and give your answer. A vector which is perpendicular to A plus B and A minus B is given by A plus B cross A minus B, and both these vectors A plus B and A minus B are given in component form. So you can find the cross product by finding the value of the determinant, and it is 16i plus 16j minus 8k. Sit plus 16i or minus 16, plus 16j or minus 16j. Different answers. Let me check. I into 16 minus 0 minus j into 16 minus 0. So it is minus 16j, I think. Isn't it? 16i minus 16j minus 8k. Right? Okay. Is this a unit vector? Is this a unit vector? The 16i minus 16j minus 8k, is this a unit vector? How can you check whether this is a unit vector? Find out the magnitude of this. See, to find the magnitude of this one, modulus of a plus b cross a minus b is equal to root of 16 square plus 16 square plus 8 square. See here, in all these three terms, 8 is a common factor, that is 8 square is common. When it comes out of root it becomes 8. Remaining here 2, 2 square 4, 2 square 4, 1 square 1. So 4 plus 4 8 plus 1 9, root of 9 is 3. Okay, so the magnitude of this vector is 24. So it is not a unit vector. We have to find the unit vector now. Unit vector perpendicular to a plus b and a minus b is 16i minus 16j minus 8k divided by 24. Dividing with the magnitude. This becomes 2 by 3i minus 2 by 3j minus 1 by 3k. This is a unit vector which is perpendicular to both a plus b and a minus b. If we change the sign of all these, that is minus 2 by 3 I plus 2 by 3 j plus 1 by 3 k, that also be a vector which is perpendicular to both a plus b and a minus b. Is it clear? Okay, let us move to the next question. If a unit vector A makes angles pi by 3 with I, pi by 3 with I, pi by 4 with j, pi by 4 with j, and an acute angle theta with k. Find theta and hence the components of A. Find theta and hence the components of vector A. If a unit vector A makes angles pi by 3 with I, pi by 4 with J, and an acute angle theta with K, find theta and hence find the components of vector A. In the first part of this chapter, see a vector A, when we write in component form, we can write this as A1I plus A2J plus A3K. This is the component form of a vector A. And you know that if this is a unit vector, A is a unit vector, what can you say about the scalar components A1, A2 and A3? If vector A is a unit vector, what can you say about this A1, A2 and A3? These are the direction cosines. Isn't it? See, A is a unit vector, then the scalar components A1, A2 and A3 are the direction cosines, or the magnitude is equal to 1. Magnitude of vector A is equal to 1, or A1, A2 and A3 are the direction cosines. So how can you find A1? Here it is given that this vector A makes an angle pi by 3 with I. I means it is a unit vector along the x-axis, that is making an angle pi by 3 with the x-axis, pi by 4 with the y-axis, and an acute angle theta with the z-axis. How can you find A1? A1 is cos pi by 3. See, this makes an angle pi by 3 with the positive direction of x-axis. Positive direction of x-axis, the unit vector is given by I cap. So this is equal to cos pi by 3 is 1 by 2. Then A2 is equal to cos pi by 4, which is equal to 1 by root 2. And A3 is given as cos theta. It is not given to us. Theta is not given to us. We have to find it. And the magnitude of vector A is given as 1. Since A is a unit vector, the magnitude of vector A is equal to 1. So magnitude of vector A is given by root of A1 square plus A2 square plus A3 square. This is equal to 1. Or squaring both sides, we will get this as A1 square plus A2 square plus A3 square is equal to 1. Substitute these values for A1, A2 and A3. Find the value of theta. A1 is 1 by 2, so its square is 1 by 4, plus A2 is 1 by root 2, its square is 1 by 2, plus A3 is given as cos theta, so its square is cos square theta, which is equal to 1. cos square theta equals, this gives 3 by 4. 1 minus 3 by 4, which is equal to 1 by 4. Cos theta equals 1 by 2, which implies theta is equal to pi by 3. Therefore, the scalar components are 1 by 2, 1 by root 2 and 1 by 2. Third A3 is 1 by 2 are the scalar components. So remember this one, when a vector A is given to you, if it is a unit vector, then the scalar components A1, A2 and A3 are the direction cosines. Otherwise, that is if the magnitude is not equal to 1, then this A1, A2 and A3 are called the direction cosines. Sorry, direction ratios. A1, A2 and A3 are the direction ratios if the magnitude is not equal to 1. If the magnitude of the vector is equal to 1, then the scalar components are the direction cosines. Is it clear? Okay, let us move to the next one. Show that A minus B cross A plus B equals 2 into A cross B for any two vector A and B. A minus B cross A plus B. A minus B cross A plus B equals A cross A plus B minus B cross A plus B. This equals distributive property A cross A plus A cross B minus B cross A minus B cross B. So this is equal to, what is A cross A? What is A cross A? Shreya, don't confuse with A dot A. A dot A is the dot product is modulus of A square. A dot A, it is modulus of A square. What about A cross A? This is the cross product or vector product, not the dot product. Okay, it is equal to 0. So remember, when we are finding the dot product, A dot A is equal to modulus of A square, and A cross A is always equal to 0. It is a 0 vector. So this is equal to 0. Then A cross B. What is this B cross A? Is this vector product commutative? Or can you apply any other result here? Is the vector product commutative? That means A cross B, is it same as B cross A? A cross B is equal to minus B cross A. Okay, so this minus B cross A can be written as A cross B. That is this plus A cross B. Is it clear? See, minus of B cross A is A cross B. Vector product is not commutative. So instead of this minus B cross A, we can write A cross B. That is A cross B plus A cross B here. Again, what about this B cross B? What about this B cross B? It is equal to 0, applying the same result. A cross A is equal to 0. The cross product of two vectors, cross product of the vector with itself is a 0 vector. So this is equal to 0. Now we can write this as A cross B plus A cross B is 2 into A cross B. This is what we have to prove. Okay, next one. Find lambda and mu if 2i plus 6j plus 27k cross I plus lambda j plus mu k is equal to 0. Find lambda and mu if 2i plus 6j plus 27k cross I plus lambda plus mu k is equal to 0. So you know how to find the cross product of two vectors given in component form. So this can be written as 2i plus 6j plus 27k cross I plus lambda j plus mu k is equal to 0 implies determinant I, j, k. First vector, the scalar components are 2, 6 and 27. Then for second vector, the scalar components are 1, lambda and mu. This determinant is equal to 0. You can expand this. I into 6 mu minus 27 lambda. 6 mu minus 27 lambda. Then minus j into 2 mu minus 27 plus k into 2 lambda minus 6 equal to 0. 0 vector. This is a 0 vector. So this can be written as 0i plus 0j plus 0k. Two vectors are equal when their scalar components are equal. So you can equate these scalar components. 2 mu minus 27 equal to 0. 2 lambda minus 6 is equal to 0 and find the value of lambda and mu. So what is the value of lambda? Equate the coefficients here. 2 mu minus 27 equal to 0. 0 vector means 0i plus 0j plus 0k. Equating the corresponding scalar components. 2 mu minus 27 equal to 0. 2 lambda minus 6 is equal to 0. So you will get the value of lambda as 3. Okay. Then value of mu as 27 by 2. Right. Value of mu as 27 by 2. Okay, let us move to the next one. It's number 5. Given that A dot B is equal to 0, and A cross B equal to 0, what can you conclude about the vectors A and B? What can you conclude about the vectors A and B? given that A dot B equal to 0 and A cross B equal to 0. A dot B equal to 0. What can you write from this? Two different possibilities are there to get the dot product equal to 0. Which are they? To get the dot product equal to 0, two different possibilities are there. What about the first one? A is perpendicular to B, or vector A is perpendicular to B, or this is one condition. What about the other one? Either A equal to 0 or B is equal to 0 or B equal to 0. These are the two possibilities to get the dot product equal to 0. Similarly, to get the cross product equal to 0, what are the different possibilities? Here also, either A is equal to 0 or B is equal to 0. Then the second one is A parallel to B, vector A parallel to vector B. See, these are the different possibilities to get the dot product equal to 0. Either A is equal to 0 or B is equal to 0. Or the second possibility is if the two vectors are perpendicular, then also the dot product is equal to 0. Then the second case, A cross B, the cross product equal to 0 when either A equal to 0 or B equal to 0, or the two vectors are parallel to each other. So here in the question it is given that A dot B is equal to 0, at the same time A cross B is also equal to 0. So what can you conclude from this? Which is the common condition here in both these cases? The common condition here is A is equal to 0 or B is equal to 0. Anyway, these two are not possible together. Simultaneously, these two are not possible. That is, A perpendicular to B and A parallel to B are not possible. So it is, we can conclude that either A is equal to 0 or B is equal to 0. Is it clear? Okay, then let us move to the next one. If either A is equal to 0 or B is equal to 0, then A cross B is equal to 0. Is the converse true? Is the converse true? Justify your answer with an example. If either A is equal to 0 or B is equal to 0, then A cross B is equal to 0. Is the converse true? This is true always. A is equal to 0 or B is equal to 0 implies A cross B is equal to 0. What about the converse? A cross B is equal to 0. Can you say that if this is true, A cross B is equal to 0, then always A is equal to 0 or B is equal to 0? Does this imply A is equal to 0 or B is equal to 0? See, in the previous question, the answer is there. Is it true that always either A is equal to 0 or B is equal to 0? To get the cross product equal to 0. See, here in this question, it is given here A cross B is equal to 0. Two different possibilities are there. The first possibility is either A is equal to 0 or B is equal to 0. This is one possibility here. The second possibility is A is parallel to B. That is, two vectors are parallel. How can you write two parallel vectors? If vector A is taken as, let us consider a vector A, I plus 2j plus 3k. Can you give me a vector which is parallel to this? Sorry, B. Parallel to A. A vector B which is parallel to A. How can you write parallel vectors or collinear vectors? In the first session, different types of vectors. How can you write collinear vectors? Scalar multiples of this. Any scalar multiple of this gives a parallel vector to A. That means if you multiply this with 2, 2i plus 4j plus 6k. This is a vector which is parallel to A. Okay, any vector which is parallel to, a scalar multiple of the given vector. And see, if we find A cross B here, its value will be equal to 0 because See now, let us find A cross B. This is equal to determinant I, J, K, then 1, 2, 3, then 2, 4, 6. If you take 2 as a common factor from this row, the two rows become identical. So the value of the determinant is equal to 0. Isn't it? Properties of determinants. If we take 2 as a common factor from the last row, the second and third row become identical. So if any two rows or any two columns are identical, then value of the determinant is 0. So it becomes 0, A cross B is equal to 0. But here A and B are not 0 vectors. So the converse need not be true. Is it clear? Okay, then let us move to the next one. Find the area of the triangle with vertices. Find the area of the triangle with vertices A1, 1, 2, B2, 3, 5, then C1, 5, 5. Find the area of the triangle with vertices A1, 1, 2, B2, 3, 5, C1, 5, 5. So how can we find the area? If vector A and vector B are the adjacent sides of a triangle, then area is equal to half of, say, a triangle ABC. Half of AB cross AC, any two adjacent sides. To get the area of a triangle, half modulus AB cross AC. So first we have to find the vector AB. What is AB? Vector AB 2 minus 1I plus 3 minus 1J, then plus 5 minus 2K. So 1I plus 2J plus 3K gives AB. Then AC is equal to 1 minus 1. It becomes 0I. Then plus 5 minus 1, 4J. then plus 5 minus 2, 3k. So we got AB and AC. Now we have to find AB cross AC. AB cross AC equals determinant I, J, K, 1, 2, 3, 0, 4, 3. Find the value of this determinant. Expand this. Minus 6i minus 3j plus 4k. Okay. Minus 6i minus 3j plus 4k. Correct. Plus 4k. Okay. Now you have to find modulus of AB cross AC. Modulus of this AB cross AC. Area is equal to half modulus minus 6i minus 3j plus 4k. Okay, it is root of 61. So root of 61 by 2 square units. It's the area of the triangle. Okay, one more question. Find the area of the parallelogram whose adjacent sides find the area of the parallelogram whose adjacent sides are given by the vectors vector A is equal to I minus j plus 3k and vector B equals 2i minus 7j plus k. If vector A and vector B are the adjacent sides of the parallelogram, how can you find the area? Area of the parallelogram, not a triangle. To find the area of the triangle, you have to find half of A cross B. See, in the last question, vertices are given to us. So, we are finding the vector AB and vector AC. See, in this question, vertices are given to us, not the vectors. So, we are finding the vector AB and vector AC. That is, this is vector A and this is, if this is considered as vector B, half of modulus of A cross B. So, when A and B are the adjacent sides of a parallelogram, what about the area? Area is equal to modulus of A cross B. Given that A and B are the adjacent sides of a parallelogram. It is not AB plus BC, A cross B. Here it is given as vectors A and B. First you have to get the difference here. In the last question, vertices are given, not the vectors or the sides. The sides are not given to us, vertices are given, so we are finding the vectors corresponding to the sides. That is why we are writing AB and BC, AC. So here vector A is given as I minus j plus 3k and vector B is given as 2i minus 7j plus k. Find A cross B. To find A cross B, get the determinant. 1 minus 1, 3, 2 minus 7, 1. So what about A cross B? It is 20i, okay, 20i, then plus 5j minus 5k. What is the scalar component of k? Is it minus 9? It is minus 5k. Okay, minus 5k. So you have to find the modulus of 20i plus 5j minus 5k. Modulus of this. Root of 20 square plus 5 square plus 5 square. 5 square is common here. So 5 into, taking outside the root, 5 into, here 4 square 16 plus 1 plus 1. 16 plus 1, 17, 18, root 18. Root 18 can be written as 3 root 2, 9 into 2. So it is 15 root 2. Root 2 square units. So we will do the miscellaneous exercise in the next class. Thank you.